brings me to the point where I am once again welcoming you, welcoming the speakers. Welcome, Dr. Benjamin Adrian. Welcome, Anastasios, Taz, Papa Konstantinou, and welcome, Dr. Teju Chalazani. We are very happy to have you here, but I would first like to introduce the Utech Chamber a little. As we are in a webinar of the Utech Chamber, and you might be, I'm sure you will be definitely interested in the work of our, in joining other webinars, for example. I'd like to introduce our alliances, our ecosystem and all this a little, in order to make you dear participants a bit more curious for the upcoming events in the future. As you see, we organize our topics in 3 alliances. Number 1 are the so-called regional alliances, where we deal with all matters regarding China, business in Africa, in Latin America, and so on. There are the tech alliances, like the one you've joined today, the Internet of Things Alliance, the Mobility Alliance, the highly recommendable Energy Alliance, where we discuss the latest trends and topics. And there are impact alliances, like the one on sustainable development or on climate action. All these alliances have numerous events. We are proud to say that we have 200 webinars per year with over 684 speakers, and they're all as high ranking as our speakers, our distinguished speakers today. We have hybrid events coming up next year. We have virtual exhibitions, and which makes the Utech Chamber very interesting too. We have 50,000 registrants, with 90% of them having a company owner and decision maker background. We grant exclusive market insights for our members in the follow-up networking meeting, and I can't emphasize this enough. You, my dear participants, you, my dear speakers, are herewith cordially invited, if your time allows it, to join our upcoming networking group meeting next week, Friday the 30th of September, in order to deepen the discussions we start today, in order to meet up, in order to network, use our networking opportunities, in order to introduce yourself. We're all very curious about the businesses, about the questions you have. So this is a very good opportunity to join our upcoming networking meetings. And well, talking about business opportunities, I can't emphasize enough the meaning of the idea exchange and cooperation. And of course, for our advocates, we offer unique access to EU tenders and worldwide funding in dedicated networking events. Talking about the Utech ecosystem, I'd like to draw your distinguished attention to the insights we gain. We offer white papers. We are currently working on highly interesting position papers, and we are going to publish them on downloadable on our downloadable pages. We offer newsletters. We have our magazine we are really proud of, called Vision for Europe. We offer award, digital transformation support, and for our members, we offer the highly interesting Tech Forum, which offers a follower database, digital and physical events, virtual booth and a highly interesting number of matchmaking opportunities. You're more than welcome to you're more than welcome to use. But of course, we're all on LinkedIn. So I am I'm very happy to draw your attention to our LinkedIn channels we have as well. I've shared I've shared you the LinkedIn links for our IoT Alliance group, for example. Please feel free to join in. We are discussing really interesting things there too. And I guess I can speak for our speakers. They are, of course, very interested in being added in LinkedIn and continuing the discussion. Continuing the discussion on LinkedIn further with you after the webinar. If you have questions, of course, please feel free to ask me anytime. I have shared my contact details too, but feel free to ask my dear colleagues Marcos Wiemann and Federico González de Aledo anytime. These are really interested in in getting contact with inquiries as well. So I can help you with the contact details for whatever reason I'm not able to see their email addresses being displayed at the moment. I don't know why. Everything happened everything worked well during the rehearsal. You see, this is a live event. I'm just really happy to share their contact details with you as well. Okay, before we start, I'd like to show you a film of our alliance, which gives you a short impression of what we are aiming at and what we are aiming at the future. Let me share my screen for you. Okay, thank you very much for your attention. And now it's up to me to announce our first speaker, Dr. Benjamin Adrian, working at the Fraunhofer Institute, Deputy Head of the Department System Analysis, Prognosis and Control, is about to do something which I really wished someone would have done at school. He demystifies science a bit more. He is about to give us a presentation on demystifying predictive maintenance. I'm really looking forward to it. Dr. Benjamin Adrian has a really impressive biography. He's a doctor. He gained his doctorate at the German Research Center for Analytical Intelligence, held different positions in companies, and then he returned to applied research. And today he is here to share his insights with you, Ben. The floor is yours. I'm going to make you a presenter.
Yeah, thank you, Joyce.
Here you are.
Okay, so thank you for having me. Yeah, my name is Benjamin Adrian. I'm working at the Fraunhofer Institute of Industrial Mathematics. Our mission is to support industry in making their business better, their production cheaper, more efficient, making higher quality. And so my role in this institute is I'm the deputy department leader of the system analysis, prognosis, and control. I think our name in this department describes the mission quite well. So we are located in southwestern of Germany, right within the Rhineland-Palatinate woods. The local, the local marketing department calls it Silicon Woods. So you're invited to come to Kaiserslautern. Maybe you heard of the soccer team. So I'm trying to give my best to demystify this strong vision of predictive maintenance and how we solve this, or how we implement systems and deploy it to customers, and maybe more important for you to give you the questions and the problems our customers come to us, and how we tackle this. So from our point of view, we are a mathematician institute, and we say, well, if you want to explain complex machines and components, also simple machines and components of different sorts, starting from small component like a ball screw, then this combined heater systems, fast drivetrains, or automotive autocranes, for example. So we really believe that math is the bridging technology. So for us, mathematics is a technology which can be deployed and used to explain, for example, a physical plant in reality, by acquiring the data, calculating with that, making a model of the dynamics the system behaves, making it conditionable and monitorable, and at least work with this model, for example, to make a prediction of the next maintenance action you should do. I think from my perspective, the most impressive and the reason why it's making so much fun is the interdisciplinarity in implementing such things for the industry, because it's not only maths. It starts with the mechanical engineers. If you have a drivetrain and you don't have a mechanical engineer in your project at hand, you start reinventing the wheel and trying to find effects which have been invented or identified 30 years ago. So it's really important to have these experts at hand. Also the electrical engineers, can you really trust what your sensor is saying to you? So such a condition monitoring predictive maintenance system, it starts with the sensor. It's part of your system, and you have to control that. Without a computer scientist, of course, the edge devices can be deployed with embedded software. Also, your dashboards won't work quite well, and without having people having this mathematics under control, you won't make anything sophisticated with the data you're acquiring, and you cannot do the modeling approach. So I think it's a real good story how different persons with different expertise have to work hand in hand to make here a successful project. The main challenge in condition monitoring predictive maintenance is that all manufacturers and all their machines and components, they're different, they're individual. All maybe the vendor is the same, or the machine series is the same, but it's used in a different way, in a different location, having faced different productions in its history and so on. However, there is one common approach and a common framework, and I'm going to show you some details into that. I don't want to go into the details here of the different customers. Just to give you an impression, we're working on cement mills, ball screws, combined heaters, industrial turbines, lamination plants, and the approach is working for all of them, but you really have to start with the machine and the product which it's manufacturing. Just to give you an example, what do we mean with predictive maintenance and our interpretation of that, which we call state-based predictive maintenance? You have here this combined heating system of Burkhardt we made a project and also product with them. And so we started with this wood pellet-based gasifier, which is one component of this combined heating system. Several sensor signals observe and monitor the gasification process there. And what we did is we took two perspectives. One is a security perspective, observing the differential pressure, and the second, the gas and how it's the different parts within the gas. And we found two condition monitors which can be used to monitor the system state here quite well. So the upper one, you see there's a linear line, going up and down, and this tooth chain pattern, it starts and ends with maintenance intervals. So you can implement predictive maintenance with a ruler, for example. So that's really nice, and we always want to come to this stage. To have such nice condition monitors and to make a model which then predicts the next critical phase of your system where you should make a maintenance action. It does not mean that your system will fail there. It just means that the chance it may fail increases. Okay. Of course, that it's all about the data. You have to acquire the data from the sensors, making it and bringing it into tabular form, and also merging it with events. So what you see here is all the operation events, and they are here on these vertical lines. And you see that the sensor signal here, it's one gas channel. It really interacts with these signals and these events. So you really have to cope with the different operation events the machine is facing. And that's where we came into bringing in a kind of a mathematical fundament. It's a framework, such to say, where we say we want to represent the input, the material, the control input, and the state of a functional unit of the system. We always observe one functional unit, not the complete system. It's too complex, but one unit, for example, the drivetrain or the gearbox, for example. And then we want to see, well, what is the control input? What is the load it's facing? What is the state of wear, its fatigue, the lubrication, and so on, and see how it produces the product and the different types of aspects. For example, the quality of the product, the performance of the production process, the availability of the function unit, how often it breaks, for example, or it produces errors, and also the energy consumption. All these are target functions, and you have to be aware what is important for you. What do you want to observe and to enhance? And the big question is, in which points do I compare these systems, and the system conditions? You have to decide, because in all these different operation points, it will behave different. You can see it here, This is it's taken from acceleration sensors, and it's the kind of amplitude energy, So you see here in different operation points, and in different operation points, you can see that different amounts of energy are consumed, or observed by these acceleration sensors. So it's called the power spectral density. And of course, if you observe this operation point with this, it's completely different, but it's the same machine. So you really have to know what is being manufactured at the moment and compare these points with each other. Another thing is here. This is a monitor of a ball screw. Where we observe the forces it faces along its trajectory, up and down its linear trajectory. And you can see here the energy levels and the wear. So which we want to observe, these points of returns where it stops and moves backward again or forward. And here the energy decreases when it faces a wear in its history. But you also see that the different sensor signals were started being observed in different points in time. So you really have to have this phase shift, yeah, being addressed to make it comparable. This is really important. So our process and how we deal with these projects is to start with the sensor and the measurement system, make a monitor for each of these things you want to know, the quality, or observe the quality, the availability, and so on, and to see how the state behaves in the good state and how it changes along time. Yeah, and if it changes, these patterns of a change, they can be used for diagnostics. And if you observe the dynamics of this change, you can use this for making a model to make a prediction. Yeah, and if you have the full understanding, you can use this understanding and put it back into your control cycle. So it's really powerful to do these steps. And I would also recommend you, if you start a project or you are a manufacturer and think, well, where do we start with? Start with the energy consumption of your system. Yeah, these meters here, they are quite cheap, and the energy consumption, it's really interesting to monitor it, to see which energy is being consumed for product A, for product B, for product C, and how it differs and why. Yeah, and to go through this process will reveal so many insights. It's incredible. Yeah. For example, we have here the power consumption of a school. This is okay. You can use this, for example, to identify seasonal consumption patterns. So what is being the energy consumption on Sunday, on Monday morning, for example, in vacations, without vacations. And the interesting thing is, when do the trend of the energy consumption, when does it change? Yeah, and why? Maybe you did something. Maybe your heaters were configured differently, for example. You can observe these change points here and identify them. And I think this is a really good point in taking actions and seeing what is the reason why the trend of the energy consumption changes, for example. It makes also your energy consumption being comparable to other products, for example, here in this example, to other schools. You can also create profiles, yeah, energy profiles of your complete production process, and to have insights. For example, if you want to sell energy of your solar panels, for example, you can use this, or even value your energy product, the energy amount your product is consuming, saying, well, this product is kind of a level in the energy perspective. For example, like your refrigerator, A++, and so on. At least in Germany, these are our ratings scales. Yeah, so it was really a quick, rough view. I guided you to all the different aspects in hopefully 10 minutes. And of course, there's so much more to say, but now I'm ready for your questions.
Thank you so much, Ben. This was really insightful, and I know talking about your field of expertise feels like time is running through the hands. Now I'd like to give the floor to Dr. Teju Chalazani, but first, quick introduction. Dr. Chalazani had some really interesting stations in his life in Dublin and New York. I'm happy to have him here. He's located in Berlin, CEO and co-founder of a company with a really strong mission. Every connected machine can share their knowledge without the need to share machine data, end quote. I've learned that the name of his company, Utpati, is Sanskrit for both profit and productivity. So, Dr. Chalazani, the floor is yours. We are more than looking forward to your presentation.
Yeah, good morning, everyone. Thanks for being here. I'm also, thank you, Dr. Adrian Benzman, for your very insightful presentation. I think it's a very, it's like a continuity from what Dr. Adrian had talked about, because even what we are doing right now is predictive maintenance too. But as you might have seen in one of his slides, that there is a small part of deep learning that came into picture, right? But the problems that we actually found with using any existing solutions in the market is that most of the deep learning based solutions need lots and lots of data. And for that, what is happening is the companies are providing IoT sensors and collecting data to their own cloud, which is external to the manufacturing company, right? Once that is happening, no manufacturing company wants to give their own data away to an external cloud, which is the biggest issue we saw when we came to implementing any deep learning based algorithms for predictive maintenance. So also what I would like to do is I would like this to be a discussion more than a presentation. So if any point of time you have any questions, feel free to stop me and ask me. This is for the presenters and the audience too. So in such a case, when companies are not willing to give their data to create these data prediction models, what can we do is the problem that we solve. And that's also something that is very interesting to me, because there is this lots of data that is coming from all the Internet of Industrial IoT sensors, but that's actually being almost sat in, inside isolated data silos around the world, and the power that you can actually get out of that data is being wasted, right? And rightly so, companies don't want to share their data because they're afraid. Let's say tomorrow there is one company that is providing sensors that collects all the data, keeps it at one place. For some reason it gets hacked or the data gets into a negative player's hand, then there is so much that they can do. So that is one of the reasons that companies don't want to give their data. So that's exactly the problem that we are solving. So underlying, if you look at it, there is this concept called federated learning. And the idea is that you don't take the data towards an AI model, but you rather bring the AI model to where the data is, right? I want you to, okay, so I want you all to do an exercise, right? I want you to think about why Google has become so powerful or Facebook has become so powerful, right? And the reason for that is they're actually collecting everything that you do and all the data to one place so that they can create these awesome prediction models where they can take all this data to one place and create models which say, okay, where is he or she going to click next? And they're monetizing that part. But when it comes to Industry 4.0, companies do not want to give their data out. So how are you going to solve this problem, right? That is the biggest challenge that we are solving. And in this way, actually, we recently finished some projects with Bosch where we connected their robotic arms, right? And then we could predict when they could fail just from, but this is without taking the data to cloud or an external source. And the way we do that is, so instead of taking all the data to one place, we create models at different locations, and we take the model updates to one place and then combine them together to make them stronger. I know I'm trying to make it simplified. I hope that makes sense to everyone. So this idea of decentralized AI, right, could be actually used everywhere. And it's actually right now being mostly used in the health tech scenario where data is super sensitive and no one wants to, no hospital or GDPR will actually prohibit you to share any of this data to one place. And it's being heavily used in that, but not much in Industry 4.0 scenario. But if we bring the decentralized AI back to the Industry 4.0 scenario, predictive maintenance would become much easier. At least it solves the problem of not having data at one place, but distributed data sources and data silos to bring them together to actually create amazing prediction models. And what this actually means is that, let's say there is a robotic arm, right? We know there are robotic arms everywhere in the manufacturing industry. So, and there are different functions that they perform, but they can broadly be classified into something like pick and place or welding or assembling, right? So if you take all pick and place robots, they have almost similar tolerances in terms of when they could go wrong. So a robot used in Bosch can also, it can share its breakdown data and the knowledge about when it could break down with a robot used in Mercedes, or with a robot used in BMW, or even with a robot used in Continental, which is competitor. And that is the aim that we are going for, and that's where we are right now. So if this is making sense what I'm saying, or you have any questions? I see there's something going on in public chat. No. Okay, cool. Since we have some more time left, I would say questions would be great.
Thank you very much, Dr. Chalazani. But as we have a block of questions coming up anyway, I'd like to first have Taz present his points. I mean, he is not going to present more than 10 minutes, and then have go ahead with the discussion on the issues the three of you mentioned. Anastasios Papakonstantinou, named Taz, is one of our Utech Chamber veterans. I strongly recommend his presentations, and he is the one to ask if to ask for scalability of your ideas and your business. He is definitely a global citizen, as you are going to hear from his almost American accent. He is deeply rooted in Europe, in Europe, in USA and US and Indian markets, and his academic background is in software engineering. And besides from that, he even finds time to do some marathon training. And I'm really looking forward for your presentation, Taz. The floor is yours.
Thank you, Joyce. Thank you so very much. And also thank you to Benjamin and Teju. I mean, your presentations were really inspiring and absolutely data driven, which I think, like all of us being engineers, we absolutely do enjoy data driven process and decisions, right? All right, so let me just share my screen. All right, Joyce, if you can upgrade me to.
I can grant you presenter's rights, yeah.
Right.
Here you go, Taz. Thanks for your reminder.
All right, thank you. All right, where is it? Okay, let me just find the correct window and let's expand that. Great. So you'll be able to see, I won't take more than 10 minutes. Strategically speaking and thematically speaking, my presentation will touch upon what Dr. Benjamin and Dr. Teju have already mentioned, but from the business applications, if you will. So, there's various ways you can definitely, go about the predictive maintenance and the IoT data-driven theorem and the discipline of predictive maintenance. I'll also share some very interesting case studies. But while I'm under NDA, I have definitely anonymized a lot of information. And who are the clients. But anyhow, let's get right to it. So very, very quickly, usually, I'm more focused on growth and also technological innovations. So at this point, I am Vice President of Business Development for Acolyte Digital, and I'm also early stage investor in climate tech, health tech, and social tech startups. I mean, it has to do with impact tech and having a specific systemic disruption, global impact, and most likely global growth potential. All right. Now, quick agenda, and the way I wanted to structure it had to do with, like, isn't predictive maintenance already good enough? But why add more information? And the cost, meaning time-wise, resource-wise, financial cost, and all of the additional costs, which can definitely be extrapolated into time and or fiscally extrapolated into money. Do they make sense in order to add another layer of information to get into IoT? Thus, that's a perfect segue into my second point, like added value of IoT. So why actually have it, and why does make sense? Why to get those lessons learned? And I think both of my esteemed previous speakers did touch upon machine learning patterns, increased knowledge, so there is business continuity. All right, some third point is some case studies that I have overseen or managed from the program perspective and program management perspective, and then moving on to a roadmap, which, by the way, also ties in with digital transformation. Most of you that may have come to a previous speech of the Utech Chamber, especially about digital transformation, will see some similarities. But just like the metaverse, IoT is also like a slice of how to include this particular theorem and this particular principle within an organization. And then key challenges, and of course, best practices. I do feel there's an immense value in always, upgrading your tips and tricks and particular way of working, just like a machine learning system and platform, if you will. Same way humans can better, in a iterative manner, always increase their knowledge. All right, so pretty much predictive maintenance. So isn't it already good enough? And some particular points, and these are data taken from 2022, have to do with reducing costs, improving uptime, and these are data-driven numbers, some average with the least sort of dispersion and deviation. So as a quick average, reducing safety, by 14, and health environment risks by 14%. So in terms of the risk register, you can say, hey, we've got these mitigation strategies, and extending obviously the lifetime of an aging asset. An asset being machine, or what Teju and Benjamin already spoke before me. All right, so pretty much just adding on top of what the previous speakers have mentioned is, what do we get out of it? What's the added value? So all in all, absolutely avoid unplanned downtime. I made it bold so somebody can skim across and really see what is the gist of this slide. Avoid unplanned downtime. Absolutely. So there's the people that are either on the field or service crew, or from the program manager perspective, or from are they, or even they're selling time and means, time and material services, can definitely empathize with the fact of the lost revenue stemming directly from downtime. Predicting machine failures is a huge one, because that means then you're going into not pretty much the maintenance, but breakdown situations, at least in the manufacturing world, and if not only just that. And obviously, if the machines are not failing, then you can have a more efficient way of utilizing them. Obviously, availability, performance, utilization, another one. Hazardous conditions and reducing those risks, which I have already mentioned before, is another major part. And then obviously response time of field service crew. And I'll get to that in these particular scenarios. So in a very specific tier 1 telco within Europe, to be honest, we've implemented an IoT-based visualization platform, data capturing from millions of IoT devices, executing then a field service management approach. So there were definite some data-driven results, and the facts of that situation had to do with a highly increased way of utilizing these IoT devices for this particular telco, tier 1 telco. As an electronic, so there was a telco case study. Electronic manufacturers, absolutely, we've already touched upon that. There was a specific I should say, okay, the various machinery were provided with some sensors. So that led to a continuous monitoring of those assets. And we were able to identify threats. Now, all that information gets to a data storage. So some persistence there, obviously, and robustness is needed. In order to get to the next level of insights. And I'll get to that in a second. And Joyce, I know I'll have 2 more minutes so we can have the discussion. I saw your face. So yeah, renewables. So let's think solar parks, wind parks. Imagine the cost of a particular solar panel or element or asset within a wind park being down. So detecting errors, understanding where material might break, some signaling towards that. Absolutely, it would be immense value in having that information. Okay, mining company. What are they doing in mining companies? Let's think about their cars. So there were like a bit about more than 10,000 rail cars. Proactive maintenance in terms of that absolutely reduces downtime. And obviously, failure as well. Okay. Collaborative product development. I really enjoy that one because it has to do with how we're getting the information, and then another abstract layer of value on top of that, which is knowledge and insights from IoT driven data and maintenance as well. So that also assists in product development. That also assists in supply chain management, marginal errors, reducing churn, product lifecycle. You can build better products if you know the ones that are actually on the field, how they are behaving. And absolutely, we are working and we're moving towards an ever more interconnected world. AR, VR, XR, I mean, all these, embellished realities, in addition to artificial intelligence and the machine learning disciplines that follow that. I mean, you might have random forest and decision tree. You have various, ML, processes and ways of working, for instance, can be intertwined, can be combined, and one can feed off the added value of the other one. All right. Roadmap. Roadmap in this particular case should be fairly simple. And why? Because it has to do with a specific slice of information that we can get, from our environment, if you will. So, which assets should be suitable, a good fit for IoT-based predictive maintenance? So, by having that in mind, you'll have a very, very particular set of machinery or assets. So then the next point would be data, quality of the data. What is the data? And I think both of the previous speakers have touched upon that one way or the other. Then predictive models. You have the data, you need to run some tests, see what are correlations, what's the text, image, or primarily text mining algorithms can provide data. So then measure, manage, and improve the insights coming and stemming from the predictive model. And finally, ML ops, or machine learning, and how to leverage machine learning to get smarter, to act smarter, to get more valuable information. Challenges have to do with the various touch points, obviously, the sensors, how they are accumulating information, the data communication. For instance, you have launched 10,000 IoT devices that are capturing data, having and lost information from partial, 10%. That's 1,000 IoT devices from whom you do not have information. That's a big number. So data communication, central data storage. I think I touched upon it before. Persistence, reliability, maintainability, all those non-functional requirement from the all software engineers will empathize with this one, and robustness. Okay, and then the predictive maintenance platform, right? How to get to a obviously robust and as much as possible error-free predictive maintenance platform. Okay, and best practices. This is what my very, very humble approach on what can make sense. So obviously start with one asset or one data set. Always iterate, measure, manage, and improve the sets, and include MLOps. Pretty much, yeah, I think that's that's my 2 cents. Thanks very, very much.
Thank you so much, Taz. And my dear participants, you see how much people presenting love to talk about the topics they deal with every day. So we got real predictive maintenance aficionados today resembled on our panel. Saul kindly handed in the first questions, and thank you very much for bringing up this really important topic. Saul asked, what about the governance and the ownership regarding all those data collected? It looks like a lot of regulation work should be done. I'd like to give this question to all three of our distinguished speakers. What do you think about the ownership and the governance of the data collected? And do you agree with Saul? Do we have some regulation work to be done?
Well, I can say something from our experience. So the data which we get from customers, it's a treasure, and it's a value for these customers. So they don't want to make it open, definitely not. So I don't think that we need a regulation there. And we need to find solutions, or to establish solutions that this data is collected where it is created, nearby the machines, and condensed in a way that you can make information out of that and conclude action items. So I think this is important. You don't need to store the data or to bring them into cloud somewhere else. You have to use them, and the industry should use it. Yeah. I think thinking about open data, and so it's from my point of view and my experience, not the correct area where we should deal with these aspects.
Dr. Chalazani, do you agree?
Yeah, definitely. And I think if we try to bring governance into this, it'll be too much. There'll be way too many politics than that already needs to be, right? So rather, what we have to use is technology like decentralization, where you don't really need to have a central database to work on. So you don't need this regulation, right? And that's exactly what we are doing, where we say that we don't want to take this data out of the trusted environment that the manufacturer has, right? And that's exactly what Dr. Benjamin said too, that you should rather you actually look at it from a technical point of view and try to come up with solutions where you can still provide this value without taking the data to a central place, so that you can avoid this pitfall of regulations.
Right, and just a final point from my end. I think I did provide some specific case studies. I mean, especially in the energy sector, in the telco sector, and obviously manufacturing. I mean, these are private networks, so regulations wouldn't really apply. In terms of the data governance, sure, that implies some internal. Well, it did imply some internal restructuring, but nothing that would be that unachievable.
Okay, thank you. I'd like to continue. I like to have you continue with the question Oliver Prang kindly handed in. Oliver asked, we always get the question of return on investment. How do you calculate the return on investment of a predictive maintenance solution at existing machines? What's your thought on that, Taz?
Right, absolutely, great question. So obviously at this point you need to have a delta. What was the previous overall cost of ownership of a particular set of assets or particular asset versus the IoT data-driven predictive maintenance route. So obviously obviously you need to make some simplifications in terms of the calculations, because having a machine breaking down and or utilizing a particular machine in various functions or processes, you definitely can split that time in the revenue generated streams. But still, it's pretty much a simple calculation. It's the delta that would be from what actually you're saving versus what was the previous situation in terms of predictive maintenance without IoT. Now, you did mention ROI, and the return on investment has to be depreciated through time. And I think most of us with financial knowledge would like to split it in over the years and depreciate it in the EBITDA. However, just to get board approval, I think it makes most sense to see, hey, previous way machines were breaking up in like 3 years. Now we're expanding them in like 6. Within those additional time, this is where we're getting out of it a lot more, and obviously incorporating the fact that there is no breakdown maintenance, but not also disaster recovery, but just a more scheduled approach towards maintenance.
Ben?
It's a very good question. So, and I always responded with an additional question. So, what is the cost for 1 hour of breakdown? If you know this, then you don't ask the first question again. The second thing is, if you know about the state of the machine and your state is good, you might think of reducing the amount of night workers of your maintenance team, which also has a large impact on your financials.
Definitely has. Pallavi Chari kindly handed in a question I'd like to read as well. For deployment of these use cases in non-green field sites, it's an evolution, not transformation, I would expect, given legacy systems. Could you talk about the challenges to overcome? I mean, we've been talking about breakdowns, so more challenges to talk about them?
Yeah, I can take up a little on this one. At least the problem with using legacy systems is that they actually do not have data being collected from their sensors. Even if if they have some kind of sensors, it's like the data is mostly transient, where you could see if there are any there is any changes in the pressure or something, but it is not collected anywhere. So it's really hard to build any AI or ML models into it, which is where you can start adding new sensors, but then that itself will bring in new problems. So unfortunately, I don't have a good answer in terms of solution itself or but there definitely one of the biggest challenges, at least we saw, was that there is no sensors or there's no sensor data, at which point we can't really do anything about it.
Ben, please add your thought on that one.
Most of the machines you're using in production, they are within a controlled cycle. So they have at least sensors for those critical parts that have to be controlled. Of course, the SPS systems are not that usable, for example, for getting and storing the data. Sometimes they only are within a 20 hertz sampling rate. Yeah, but the sensor exists, and you can reuse them. The only sensors which we added as a retrofit by now is maybe some acceleration sensors or some gearboxes and so on. Yeah, which are quite cheap and but really meaningful. And the thing is, you don't have to observe the complete machine. Only some critical functional units, should be observed, because they might break down or have huge costs for maintenance. So really focus on those parts who are critical and see how they are controlled in your control cycle, and maybe add some acceleration sensors. I think this is the 2080 rule. Without getting too much into costs.
Thank you, Ben. I am overwhelmed by the participation of our audience in the discussion, but unfortunately, I've got to watch the time a little. So I'd like to thank everyone for coming. I'd like to thank our speakers for this really insightful presentations on predictive maintenance. I'd like to urge everyone to take up contact to the speakers on LinkedIn, and I would like to cordially invite everyone to join our next week's business network and business meeting, taking place at 9 a.m. too. Those who are already advocates at Utech Chamber know what I'm talking about. There's just click on Tech Forum, register for the networking meetings. And those who are not advocates, already aren't advocates of Utech Chamber, we offer a trial advocacy. Redeem your trial advocacy on the link I'm going to share in the chat. And as said and promised, our speakers not only contributed to our expansion of knowledge today, they also contributed to fighting climate change. We, as Utech Chamber, plant for every presentation held a tree in Africa. So thank you very much, Dr. Adrian, Dr. Chalazani, Tas Papa Constantino, for coming, and thank you very much for your contribution to fight climate change. I'm going to send you the tree certificates via email. Thank you very much for coming. Enjoy your Friday, enjoy your weekend, and join in for the next webinar of Utech Chamber. Thank you very much.
Thank you all.
Thank you, Joyce.
Have a great day.
Yeah, thank you all.
Bye.